Now the complete transfer function is available except the gain k. Now we'll see how to find gain k. We know to find gain k, we need to look at the magnitude plot. In that plot, we should find out at known frequency what will be the known MdB value. So it is given that at 0.1 frequency I have 12 dB. So these two information is enough. Now what will be the first term? It is k by s square. So when you have k by s square, what will be the MdB expression? MdB is 20 log k minus, we have minus 40 log omega. So omega is 0.1 and this is going to be 12. When you equate, you can find out the k value. The k is going to be 0.04. Then what is my total transfer function? Transfer function is 0.04 into 1 plus 0.5 whole square into 1 plus 0.2s divided by s square into 1 plus 0.1s whole square. So this is in time constant form. You can also write down in pole zero form. Then you can find out the corresponding transfer function. So this way we can find the transfer function. Let us look at another magnitude plot and let us find the transfer function. The problem statement goes like this. The open loop frequency response of a certain control system is shown below. Obtain the transfer function. So the magnitude plot is like this. Now in this magnitude plot, you can just look at the plot and you can count how many slopes are available. Now I have 0 dB and I have minus 20 and also I have minus again 0 dB and I have 20 dB for minus 20 dB for decay. Therefore there are 4 slopes, means you will be getting 4 terms in that. Let us see how to find all the terms in this case. We can look at the initial slope. The initial slope is 0 dB for decade. When initial slope is 0 dB for decade, then what will the corresponding term? It is k. Now step 2, we can look at what are the corner frequencies. So we have corner frequencies 5, 10 and 50. So each and every corner frequency you can find out what will be the term. So if you look at the terms, you have at omega c1 the slope will be minus 20, which means there will be 1 0, 1 by 1 plus s by 5. Then similarly at next slope, then we have one more pole here. Then what will be 1 0? So we have a plus 20, therefore 1 0, it is 1 plus s by 10. We have initial slope. The initial slope is 0 dB for decade. Whenever you have 0 dB for decade, the corresponding the first term is k. So the first term k directly we can write down. And also we have the corner frequencies, 3 corner frequencies at 5, 10 and 50. So at each and every corner frequency, I want to know what is the respective slope contribution. The slope contribution will be the next slope minus previous slope. So at omega c1 is 5. So that is minus 20 minus 0, that will be minus 20 dB for decade. So whenever you have minus 20 dB for decade, then the term will be 1 by 1 plus s by omega c1. Omega c1 is 5 here, therefore term will be 1 divided by 1 plus s by 5. So this is the corresponding term for the omega c1 radian per second, 5 radian per second. Next is omega c2. Omega c2 we have 10 radian per second. Here we can write the next slope is 0 minus of minus 20. So the corresponding dB will be plus 20 dB for decade. The slope is plus 20. So plus 20 means it is a 0 term. Then 1 plus s by omega c2. So omega c2 10. So 1 plus s by 10 will be the corresponding term. Similarly to omega c3, then we can find out what will be the slope contribution. That is again minus 20 minus 0. It is minus 20 dB for decade. So minus 20 means again it is a pole. So 1 over 1 plus s by omega c3, that is 1 by 1 plus s by 50. So we have 3 terms which we have got like this. So next we can write all these things in the transfer function. The transfer function will be a k is at the first term, then I have 1 plus s by 10 divided by I have 1 plus s by 5 into 1 plus s by 50. So this is a transfer function. In this transfer function I need to find what will be the k value. You can simplify later. Then to find the k value, I need to look at what will be the initial slope and the first term. Initial slope is 0 dB for decade. Therefore, what will be the corresponding MdB value? You can look at that. MdB value is going to be 20 dB. So if 20 dB is there, directly I can substitute 20 dB is equal to 20 log k, then you can find out the k value. So whenever you have a 0 dB for decade, the corresponding term is k, then mdb is equal to 20 log k. There is no omega at all because it is a straight line which is parallel to the x-axis. Then we can find out what is the corresponding k value. The k value is going to be 10. Now what will be the final transfer function? 10 into 1 plus 0.1s will divided by 1 plus 0.2s into 1 plus 0.02s. So this is the corresponding transfer function of the given open loop frequency response. So similarly, we can look at another example, and the problem statement goes like this. Find the transfer function for the system whose magnitude plot is shown in the figure. So this is a magnitude plot given, and again you can look at how many number of slopes we have. 1, 2, 3, 4 slopes, means 4 terms are going to come, and there are 3 corner frequencies at omega is 4, 8 and as well as 20. 4, 8, 20, 3 are the corner frequencies. Now we can also see that initially at omega is 0.1, it is given that it is minus 12 dB. So this information at omega is 0.1 minus 12 dB information is very useful to find the k value because it is the initial slope. On the initial slope we have these values. Now, so I have 4 terms. Let us see how to find all 4 terms. These 4 slopes, they are given in terms of the dB for octave. If you look at the initial slope, it is given as a plus 12 dB for octave, then we have 0 dB for octave, then I have plus 6 dB for octave, and again I have minus 6 dB for octave. We know decade is there is a 10 times change in the frequency, octave is 2 times change in the frequency. But we have the relation between dB for decade and dB for octave. What will be that? So 20 log n dB for decade is equal to 60. 20 n dB for decade is equal to 6 n dB for decade. 20 n dB for decade plus or minus 6 n dB for decade. We need to identify what will be the n value. If you know n value, then I can substitute n value here, then I can find out what will be the dB for decade for the corresponding dB for octave. Now initial slope, it is given it as plus 12. So plus 12 we can write it as 2 into 12. Then what will be the corresponding dB for decade? It is going to be 2 into 20. It is 40 dB for decade. The initial slope is now in terms of the 40 dB for decade, plus 40. Then 0 is 0 only. Again I have plus 6 dB for octave. That will be plus 20 dB for decade. And the last slope is a minus 6 dB for octave, which means minus 20 dB for decade. So whenever dB for octaves are given, it is always better to convert them into dB for decade because all our calculations are with respect to dB for decade. Now look at the initial slope. The initial slope is now in terms of dB for decade is plus 40, which means the corresponding term is going to be k by s square. That is the first term. Then in step 2, then we can look at all the corner frequencies. Omega c1 is 4. What is the slope at that omega c1? It is going to be 0 minus 40. That is minus 40 dB for decade. Whenever you have minus 40 is 1 divided by 1 plus s by omega c1 whole square. Omega c1 is 4. Therefore I can write 1 divided by 1 plus s by 4 whole square for the corner frequency omega c1. Then at omega c2 is 8 radian per second, we can write it as, already we have 0 as the present slope, and the next slope is 20, therefore 20 minus 0 it is going to be plus 20. So plus 20 is 1 0, therefore 1 plus s by omega c2 is 8, therefore 1 plus s by 8 is my term. Then what will be at omega c3? Omega c3 is at 20 radian per second. Then the last slope is minus 20, and before that I have plus 20. So minus 20 minus of plus 20, that is going to be minus 40 dB for decade. Minus 40, again there are 2 finite poles in the denominator, that is 1 over 1 plus s by omega c3 is 20 whole square. So I can write the transfer function in terms of k as, already k s square is the initial term, the first term, 1 plus s by 8 divided by, I have 1 plus s by 4 whole square into 1 plus s by 20 whole square. This is the transfer function. But in this transfer function I need to find what will be the k value. So to find the k value, let us take the first term, which is k s square. Then you know the expression mdb is 20 log k plus 40 log omega. And as we can see from the diagram, the initial slope at omega is 0.1, I have minus 12 dB for decade. So mdb is minus 12 and omega is 0.1. When you substitute in this expression, you can find out the k value. The k is going to be 25.11. Then what will be the total transfer function? It is 25.11 into 1 plus s by 8 divided by 1 plus s by 4 whole square into 1 plus s by 20 whole square. This is the open loop transfer function of the corresponding magnitude plot given.